So in this example, we're given a simple circuit that has a voltage source, 72 volts, a current source of 18 amps, and we're asked to find the current I, which is this current flowing here through this 16 ohm resistor. And they want us to do this by using superposition. So that means we consider the contribution from each source separately and then combine them at the end. So let's go about seeing how this works. So first we want to consider the 72 volt source, the contribution from that. So when we do, that means that the 18 amp source would then be open circuited. So that means we could just take it out of the circuit here and leave that open. So when we do that, we see that we could redraw this circuit then as follows. We would have the 72 volt source. We'd have our 8 ohm resistor on the top. We have this 8 ohm resistor here. And then we can combine these two 16s to get a 32 ohm resistor there. So we see that the 8 and the 32 are in parallel. So next we need to determine what the total current, we'll call it IT1, is coming from our source. But to do that, we're going to have to find what the RT total resistance is from our circuit. So to do that, RT total, RT1, is going to be this 8 ohm resistor in series with these two resistors in parallel. So that's plus 8 in parallel with 32. So we could write that as 8 plus 8 times 32 over 8 plus 32. And when we calculate that out, we should get 14.4 ohms. So then we can find our I total from the first source. That'll just be our voltage source over RT. So that's 72 volts from the circuit. RT we just calculated. And so that should be 5 amps. So that's what's flowing from our source right here, 5 amps. So now we see, looking back at this circuit, that we have this 5 amps coming here, and then we're just going through a current divider. So that means our I from the first source would just be equal to our I total from the first source times our other, which means the other branch that we're not interested in. In this case, it's this 8 ohm branch, because we need to know what's going through the 32 ohm branch. That's what's going to be our I value here over our total for the branches. And so in this case, that's going to be 5 amps times 8, we said was the other branch, over 8 plus 32. We want the resistance for both branches in the bottom. And so when we calculate that, that turns out to be 1 amp. So that's our contribution from the first source. So we'll draw a line here. Now we want to consider the second source. So in that case, that'll be the 18 amp source. So when we do that, the voltage source now shows up as just a short circuit. So we can modify our diagram up here now. So we'll take the voltage source out, and then we'll draw this as a short circuit across here. So we just short it out. So this is what our new circuit would look like. And so we see that that makes these two resistors in parallel. So then we could replace those two circuits. Anytime you have two resistors of the same value in parallel, that just halves them. So then we can now replace all of this. And get rid of this branch here, and this resistor here, and we can replace this now with just a 4 ohm resistor. So now we should be able to see, if we redraw this in a way that might make it a little easier for us to see, we've got our 18 amp source. We've got it in parallel with 16 ohm, and then that's in parallel with another 16 ohm, which is the one we care about, and this 4 ohm resistor, so 16 and 4. And so our I that we're interested in is actually going through this outside branch. And so this again is just a current divider. So we can write this pretty easily then. So now our I2 is going to be 18, which is our current source, times the branch we're not interested in, which is this branch. So that's 16 over the total. So that's going to be 16 plus 16 plus 4. And so when we add all that up, what we get is 8 amps. Now we need to also keep in mind that we define the direction of the current going this way. So this one checks out. We have 1 amp going that way from our previous source, but this one's going to go the opposite direction. So therefore this is going to need to be a negative 8 amps because it's going in the opposite direction of what we're showing there. So now we have the contribution from each source, 1 amp and minus 8 amps. We can now take that and calculate everything. So our I is going to be equal to our I from the first source plus our I from the second source. So the first source was 1 amps, the second source was minus 8 amps. So then the total current flowing is minus 7 amps. And so that means it's negative because we're showing the current going this way when in fact it's actually 7 amps going backwards, back against that.